unveiling the Titanic, a dive into the data. Good evening everyone, this is Harshita Sanjana R from 3rd Sem CSEA from VNMIT. Today we embark on a journey of history's one of the most tragic as well as iconic event, the sinking of Titanic. But fear not, as we won't be traveling through icy waters or we won't be encountering any huge icebergs, but instead we will navigate through the vast or the sea of information about the Titanic. We will explore the stories it holds and the insights which it can reveal. So here is my Titanic dataset which I call, and then the main problem statement and the main analysis and the main or the ultimate goal which this data set can provide us. I am going to tell about this in a few moments. So here is the data set. As I said, the columns, as you can see, are the 12 in numbers, and the rows are around 890. There are around 890 rows, as you can see, like the 890 rows, as you can see, 891 rows, as you can see. So coming to each of the columns, the first one we can say, let's say it is representing over the passenger ID, and then survived, whether the passenger survived or not, and then whether the third column represents the passenger class, and the fourth one, fifth one, sixth one represents the name, gender, age, and the SIVSP column represents the number of siblings and number of spouse the person or the passenger had when on board. And next was about the parents and children, and next was about the ticket, fare, and cabin, and embark. Embark represents the place from where the person boarded. Like for example, S for Southampton or Q for Queenstown. As I said earlier, I'll be touching upon the main problem or the main topic and the main ultimate goal and the analysis of this dataset. I'll be touching upon it now. The main problem this dataset is addressing is survival prediction. As you can see, if the passengers survive, it is 1, or if not, it is 0. So the survival prediction is based on various factors, like it is based on either of the, whether we can check whether it is based on gender or age or siblings or spouse or the socio-economic status, or whether it is dependent on the ticket and fare and the cabins. So that concludes the main problem. And now coming to the analysis part, the analysis can be done via data visualization or adding new information necessary for the relevant fields necessary, relevant attributes necessary, and we can also build predictive models for it also. The ultimate goal so obviously becomes predicting the exact whether the exact values, whether the passengers survived or not. So let's not delay and let us deep dive into the visualization of this data set. So this is, I have imported the pandas library, as you can see, and this represents the whole data set is displayed on the screen. And then df.shape represents the number of rows and columns which are present, the rows being 891 and 12. I want you to take note of this as I will be touching upon this later. So 891 rows and 12 columns. And then df.ticket represents the ticket information about each of the passengers which were on board. And df.information represents the info about all the passengers, and then df.head represents only the necessary, like the starting few passengers summary and the information about them. df.tail represents the last few information about last few people's information about, and df.describe represents the summary statistics of the whole passengers, of all the passengers. And then I have imported the specific libraries which I am going to implement later on. Next is correlation, df.correlation, print. I have printed this all the values, and then I have just printed the bar plot of those who have survived. And next comes the histogram plot, like it touches upon the age distribution. What was the age distribution of all the people present? Like, was it, as you can see, it ranged up to 70, like even elderly people were there and even the children were there, everyone of all the age groups were present on board. So this was the histogram of the age distribution. The next represents the histogram of cabin column. So this I can use it for whether this cabin column had the highest survival rates or whether this cabin column had higher survival rates. And then the next was about survival by gender, whether we can check whether the males survive more or whether the females survive more. And as you can see, females survival rate was more and the males death rate was more, and the female survival rate was more from this graph. And then next comes the heat map of the whole data set. And I have used other palettes for just for the data visualization techniques. So one was this was rainbow, and the next one I have used is RDPU, which is a red color palette, and then next is Viridis. I have also used Viridis, and then pair plot. Pair plot, this represents the relationship between like two or more variables. We can see the passenger ID or survival rates or like P class or the passenger class and the survival rates can be like relationship can be obtained from this graph. We can actually predict, like we can see the relationship between them, and we can actually like encounter and predict all the values as we want. And then this while I was researching about various plots and various graphs, this was the violin plot. Probably the name itself is like a violin, like it looks like violin, so I guess they have given that name as violin plot. And I have used it for survived along the y-axis, and the x-axis represents the age. Like this also can be used for age versus survival. Like which age the people survive more, like was it the elders who survive more or was it the children who survive more? We can get to know about that. And the next one is box plot. Box plot I have used for the fair distribution. As you can see, the title is fair distribution by class. Box plot I have used for fare versus the passenger class. Like obviously passenger class 1 is the highest fare. Like it is arranged in the decreasing order. Passenger 1 has the highest fare and passenger 2 has the next middle amount, and passenger class 3 has the lowest rates. And next one is survived. Print, like I have to know the counts of those people who survived or those people who couldn't survive. So as you can see, this I have the data of 891 as I mentioned earlier. So 549 was the not survived people's rate, and one was one represents the people who survived, that is 342. And then as I said earlier, there were 12 columns which were in the beginning. So I have included in this DF family size represents the another column which I am creating now. So basically I am adding another column. To our requirement we can add another column which can be used for data analysis. So family size I have created by combining the two columns as I mentioned earlier, the sibling spouse column and the parents children's column. So after that I have df.shape, then the new column is added, so it is 891 rows and 13 columns, and missing cabin rows. So there, as I saw the data set, there were around like many missing columns, like in the cabin column there were many missing data. So not all the cabin values were, not all the cabin data was known. So via this I can get to know the rows with missing values in the cabin column. So these were the missing values in the cabin column, as you can see. These were all the missing columns which all had the cabin column missing values. And then this is the crosstab. Crosstab is I have used this for the cross tabulation between the name and the fare, just for the cross tabulation, so that it obtains a relationship between the name and the fare, like who paid how much and who paid like how much money. So and then sort values. This is another one I have implemented which sorts the values based on the descending order. So I have to check whether the elders survive more, because they might have been given the more priority since they are aged people. So I have sorted the values. So then I have printed only the starting value. Since it is sorted in the descending order, I have printed only the starting values and not all the values. So as you can see in the second one, you can see the age differs from 80, 74, 71, 71 and 78. So it is already arranged in the descending order. So this was which I implemented, and then thank you for joining me on this journey, data-driven journey. I hope this acts as a foundation for exploring and discovering new technologies and new stuffs which from the vast information available to us. Thank you.